Hey everyone, welcome back to CFD Simplified. In this video, I'm going to walk you through a complete simulation of flow over an airfoil in OpenFOAM. Okay, so let's start this tutorial. So first we will open the tutorials of OpenFOAM. Then we will go inside incompressible. Then we will go inside simpleFoam, and here we will find airfoil 2D. Okay, so let's start this analysis. So first we have to copy this for our to our home directory. It is here. Okay, yes. So here in this tutorial, what they've done, they have already given us the polymesh files. Okay, we don't have to go for the BlockMesh because they have not written any BlockMesh dict or any SnappyHexMesh. Okay, so they directly gave us the polymesh files. Okay, if you can go inside the constant, you will find polymesh.org. Here it contains, the files of it. If we go and open, okay, so yeah, you can find these files. Okay, so we have to just make a folder of polymesh inside the constant directory and then copy these one. Okay, if you go, if I'll show you the all run file, it looks like some type of complex thing. Okay, so we'll not go with this one. Okay, we will do it by our own. Okay, always my suggestion is like always go for the to not use the all run command if you are running the OpenFOAM simulation from a tutorial. Always uh, try to run it by your own, by understanding the process, because it will be more beneficial to you. All right, let's start this. All right, so what we will do, we will just type this command to copy this is cp minus rf, because you can see that it contains the extension .gz. So for that you need to give this command. We cannot give another one. All right, so like we have given here to copy this one. Okay, so we have to give this rf specifically. So constant polymesh.org, then we have to type the path where we have to copy this constant and polymesh. Okay, press enter. Okay, let's go and check. Yes, polymesh directory has been created. Inside that you can find that all these things are here. Okay, don't worry about .gz, it is readable, no issues in that part. Okay, no issues in that part. All right, so we will go back. Yes, now we have to run, we have to copy this 0.org to 0 directory, because OpenFOAM reads 0. Okay, this will be the initial boundary conditions. Okay, so let's copy cp-r 0.org to okay, we'll type ls 0. Yeah, all the boundary conditions are here. All right, so then we have to go to the system. Why? Because it will require parallel processing, and I am having only 4 cores on my laptop. Uh, yeah, but the original tutorial has been made for 8 cores. Okay, I'm having 4 cores, so I have to change it. So we have to go to number of domains and change it to 4, and then we have to change the coefficient also. So I will just use, in place of 4 I'll just place 2. Okay, then press O, because you have to change both of them. Okay, if you wanted to change the number of subdomains, specifically the number of cores. I have described about it in our decompose par tutorial. You can go and check it out there. Okay, press Ctrl C, then I will just press decompose par, press enter. You can see that here it is 0 4 processors has been made. Okay, 0 1 2 3. All right, then as everything is fine, then we have to go for simpleFoam, because the solver which is used to solve this is simpleFoam, but we cannot go, because if we write simpleFoam, then it will run only single core. If we have done decompose par, if you wanted to run multiple cores, you have to type this command simpleFoam, and then we have to just uh, it will take some time to solve, and after that it will be, the simulation will be completed. So yeah, it will take 3 to 4 seconds. All right, so we can just wait till then. After that, we'll just go and analyze the results in the ParaView. Okay, till then let me do some things. Yes, so simulation is complete. It has written we don't need to run reconstruct path, because it has already written the directories, the time directories outside. So yeah, okay, if we run, it will ask for the time and everything, but yeah, I think we don't require to run. Okay, fine. So after that, we will just first make touch foam.foam file, and then we will just go to paraview.exe foam.foam. Okay, you must be having one thing, that why I have not made on the installation of the ParaView, because if we will, something was happening, I tried to help two of my friends with the installation process. I know, but it was not working, so that's why I'm working on that part. Once I will just clarify that one, then I'll make the video on the installation of ParaView. Okay, because there must be some confusions on that part. All right, so yeah, here you can see that this is the airfoil, and it is showing the pressure, so you can find the pressure contour. Okay, So first let's go to the wireframe and check the mesh. Yeah, here you can see the mesh has been generated. So this mesh has been generated with the help of the this SnappyHexMesh only, or they have made this mesh in some 3D software. You can make the mesh and everything in a 3D software, then you can transfer that mesh into the OpenFOAM. It's a very simple thing, and then you can use it. So all right, I'll discuss about that in another video. Okay, so let's move on. I'll just tell you about that. Okay, because video will get longer and longer. All right. So yeah, this is the mesh for this case. Okay, so this is the one. So let's again go to the U and go to the surface. Here you can see that this is the velocity contour we have got. So if we'll go to the next one, at 100 seconds you can see the velocity is like this, 150 it is like this, 200 it is like this, 250, 300, 350, and in the end it's 500. Okay, so let me so you can see that after 200 seconds you cannot see any major changes. Okay, so yeah, it means something must be happening between 100 to 200. Okay, so if you wanted to run between 100 to 200, you can run it, because the in the control dict file, if you can go and check. Okay, in the control dict file, so here they have written the right interval of 50. Okay, and end time at 500. End time is fine, but yeah, here you can just uh, you know uh, change it of the writing time like 10 seconds. Okay, so yeah, the file will be very long, but yeah, you will be able to analyze the results. Okay, all right, so this is the thing. But what issue I am having, it is not calculating the force coefficients. Okay, because if you cannot get lift and drag, I think it is of no use. Okay, so if you can see in the boundary conditions also, they are getting U and pressure. Okay, but there is nothing about this one, this no, the lift and drag. Okay, so how can we get that one? How can we get lift and drag? Okay, so we have to make some changes and add something basically in control dict file. Okay, before we continue, if you are working on a CFD, OpenFOAM or engineering simulation project and need personalized help, I now offer paid support and consulting. Whether it's setting up your case, debugging issues, or developing custom solvers, I'm here to help you move forward faster and more confidently. Just reach out via email in the description. Let's make your project a success. So let's go and see how we can do that. We will, yeah, let us close this one. Okay, I mean, I am just telling you about how to, you can generate the force coefficients. There is one library named libforces. So, but yeah, I mean, the values which I am taking, it may not give you the correct or exact value of CD and CL. CD is the drag coefficient and CL is the lift coefficient. But yeah, with the help of this you can calculate. Okay, directly. You can get a one data of this. Okay, so what you have to do, you have to go inside this system, and then you have to go inside the control dict. Okay, so here in the end, add this thing, add this one. Okay, add this one. So control C and control V. Okay, so here you can find that I have made one force coefficient and type this one, and here given some values to these variables, and we can get the things from here. Okay, so after doing that, you have to save it, go back, remove each and everything, remove every timeline, time step, everything you have to remove. So first we will remove the processors. Okay, then you have to remove the the time steps, 100, 150, 200, 250, 300, 350, 400, 450, 500. Yes, it is on to 50 also. What I'm doing. Okay, now just simply run the, first we have to run the decompose par, and after that we will run the mpi run -nv for simpleFoam. Okay, so now it will start calculating the, you can see that yes, it has given some error. Okay, I know it has given some error. It is why this is coming, because it is dividing by 0 or something, something wrong is going on. Yeah, but with the help of this you can generate the this one, this file. Okay, so here you have to go to the force coefficient, and inside 0 you can find the data is there. Okay, if you open what I'm doing. Yes, so here you can find we have CD drag coefficient, we have CL lift coefficient. Okay, so yeah, I mean I am accepting that the values are not, maybe not correct. Okay, because it has not completed the full simulation. Also it has given some that some very bad value is coming. I know error has came, but yeah, I mean I just wanted to show you that in this way you can calculate the values with respect to the time steps. Okay, that is the thing which I wanted to show you. So yeah, what I am thinking is like in the next video, what I will do, I will just find some research paper online. Okay, online research paper, and try to simulate that one for you in OpenFOAM. Okay, regarding this NACA Airfoil only, we are, yeah, for this case we are using NACA Airfoil, I think 2010, if I'm not wrong. Okay, you can find this on Google. I think it was NACA Airfoil 2010. Okay, so I will just try to find some research paper, then we will try to calculate all this CD, CF, CL. All right, then we will make the plot also in another video. Okay, in this video my point of view is like how you can run this tutorial, and if you wanted to calculate, like if you are stuck, that the values correctly, but you are having some issues in calculating CDCF with the help of the simulation, you can do it with this way. Okay, yeah, some more ways can be there. I found this one useful. Okay, you can use another also, and you can use this one also. Okay, if this is wrong, if the wrong values are coming in other parts of if you are keeping the values correctly but still you are getting some wrong values, then you can just comment it down and tell me that okay, this method is wrong. Then I will try to rectify it and give a correct one. All right, because I am also learning. I'm not the expert of the CFD, but I am also in the learning phase. And CFD is very vast. CFD is very complex. But yeah, I mean that much I know. I just try to help you all guys. All right. So yeah, let's end this, and we will meet in the next video. If you found this tutorial helpful, drop a like, comment below with questions or suggestions, and subscribe to CFD Simplified for more practical CFD workflows.